Water. Water everywhere, but not a drop to drink. That's the situation around a young star called PDS 70, where two giant planets are making water out of thin air. This is one of the most surprising and exciting discoveries ever made by the James Webb Space Telescope, and it could have huge implications for the search for life in the universe. The star we're talking about today is PDS 70, which is so far away from us that it takes 370 years for its light to reach us. That means we're seeing it as it was in the 17th century, when people still thought the Earth was flat and witches were real. And honestly, we don't need to time travel to the 17th century for that comparison, but hey, no judgment here. Anyway, PDS 70 is also a very young star, only 5.4 million years old, which is like a baby in stellar terms. It's still learning how to make planets out of the gas and dust that surrounds it in a thin and flat disk. But it's not very good at it, because its disk is all messed up. It has a huge gap in the middle, where two big bullies called PDS 70b and c have pushed away all the other stuff. These bullies are gas giant planets, similar to Jupiter and Saturn, but much ruder and more selfish. They were first discovered in 2018 and 2019 by using infrared telescopes on Earth, because they're too shy to show their faces in visible light. But what about the inner region of the disk, where rocky planets like Earth usually form? Well, that's where things get really interesting. A team of astronomers from Europe, including researchers from Dublin Institute for Advanced Studies, or DIAS, used a new and powerful instrument called MIRI, or Mid-Infrared Instrument, on board the James Webb Space Telescope to observe this region for the first time. And what they found was astonishing. Water vapor near the disk center close to the host star PDS 70. That's right, water vapor, not ice, not liquid, not solid, but gas. Now, water isn't exactly the introvert of space. You'll find it in frozen forms on comets, asteroids, moons, and even some planets. But finding water in its gaseous form in the inner region of a planet-forming disk is very rare and surprising. That's because water molecules are very fragile and easily destroyed by the intense radiation from the nearby star. I mean, we're talking about a region that's very close to the star. So the million-dollar question, how on Earth, or well, in space, did this water survive or form in such a hostile environment? One thought is that the water might be a leftover from an earlier stage of disk formation, when it was more water-rich and less exposed to radiation. Or maybe the water came from the outer regions of the disk, where dust and ice shielded it from the star's radiation, and then moved inward due to the gas drag or dust growth. And just for fun, let's not forget the possibility of some space chemistry, with oxygen and hydrogen gas making water right in the inner disk. The truth is probably a combination of all these scenarios, but the researchers are still working on figuring out which one is more dominant or important. In any case, the presence of water in this region has huge implications for planet formation and habitability. You know, water is basically life's VIP ticket on Earth. But the funny thing is, we still don't know how it ended up here in the first place. One popular theory is that it was delivered by comets and asteroids that crashed into our dry and dusty planet a long time ago. Sounds good, but wait, there's more. This cosmic water delivery service could have also happened for other rocky planets orbiting distant stars. But of course, it's not that simple. The timing and conditions must be just right for this to work. But hey, what if some rocky planets hit the jackpot and were born with a built-in water supply? What if they formed in a water-rich environment, like the one around PDS 70? Well, that would make things much easier and faster for them to become potentially habitable later on. They would have a local water reservoir that could provide them with oceans, lakes, rivers, clouds, rain, snow, ice caps, and maybe even life. Talk about being spoiled. But water is not the only thing that makes a planet habitable. You also need other things, like the right size, mass, composition, atmosphere, magnetic field, and distance from the star. But water is definitely a big deal, and finding it in the inner region of a planet-forming disk is a very good sign for the search for life in the universe. So far, the researchers have not found any rocky planets in the inner region of the PDS 70 disk, but they are not giving up. They're planning to use more observations from JWST and other telescopes to look for them. Maybe they'll find some Earth-like worlds that are born with water and have the potential to host life. Maybe they'll even find some signs of life itself. Who knows? Well, we've explored the what, so now let's dive into the how. How did JWST find water in the inner region of the disk around PDS-70? You see, it didn't just sniff it or taste it, because that would be gross. No, it used a much smarter and safer method. It looked at the light. You see, light is not just a pretty thing that makes us see stuff. It also carries information about what it touches along the way. And MIRI is like a detective that can decode this information by using a tool called a spectrograph. A spectrograph is a device that splits the light into its different wavelengths, like a rainbow but with more colors and details. It shows us how much light there is at each wavelength, which are like the sizes of the light waves. And different things in space have different signatures in the spectrum, like fingerprints or barcodes. For example, water has some signatures that look like dips or valleys in the spectrum, where it absorbs light at certain wavelengths. These are called absorption lines, and they indicate the presence and amount of water. And by measuring how deep these lines are, MIRI can tell how much water there is and what temperature and pressure it has. But wait, that's not all. MIRI has another trick up its sleeve: spectroscopy. Spectroscopy is the study of how matter interacts with electromagnetic radiation such as light. MIRI uses spectroscopy to measure the spectra of the disk and planets in the mid-infrared range, where water and other molecules have strong signatures. And it has 18 mirrors that can work in different modes to capture these clues. And again, what MIRI found was that the water was mostly hanging out near the disk center, close to the star PDS-70, where it should be too hot for water to exist. So what does this all mean? Well, it means that we have a lot to learn about how planets form and how water behaves in different environments. It also means that we have a new candidate for finding life in the universe, because where there's water, there's hope. And maybe, just maybe, there's a chance that somewhere in the inner disk of PDS-70, there's a small planet with a tiny ocean and a tiny fish that's looking up at the sky and wondering if there's anyone else out there. Or maybe not. Maybe it's just a bunch of water molecules that don't care about anything. Maybe we're all alone in this vast and cold cosmos. Maybe we should just give up and stay at home. Thanks for watching. And don't forget to like and subscribe. Yeah, that was fast.